Eurocode 7 is the first European geotechnical design code to share a common philosophy with the design methodology for structures. It's divided into two parts, the first covering general rules and the second ground investigation and testing. Part 1 is subdivided into 12 sections and 9 annexes and provides a general framework for geotechnical design, definition of ground parameters, characteristic and design values, general rules for site investigation and rules for the design of the main types of geotechnical structures. Part 2 is subdivided into 6 sections and 24 annexes and provides detailed rules for site investigations, general test specifications, derivations of ground properties and the geotechnical model of the site. In this programme, we're going to be picking out some of the most significant aspects of Eurocode 7. And joining us in the studio to help us do that, we have Andy Harris from Tony G and Partners and Andrew Bond from Geocentrics. And Andrew is also the chairman of the Eurocode 7 committee. And both Andy and Andrew are co-authors of this book here. It's called Decoding Eurocode 7. Well, thanks very much indeed for joining us, gentlemen. Andy, can I start with you first of all? This is quite a mighty tome, but presumably that's important because what we're talking about here is a considerable change, isn't it, for geotechnical engineers?
Yes, it is a big change for geotechnical engineers, presenting a different approach to the way in which we carry out geotechnical design. And what we try to do in our book is provide a comprehensive background to the new code and its many parts, but also make it very user-friendly in the way we put it together so that people can actually use it to carry out designs and to approach their work in this new way.
OK, and Andrew, I mean, the aim here with Eurocode 7 is presumably to get a more unified approach right across Europe for the first time.
Yes, the practice across Europe has varied considerably in geotechnical engineering because ground conditions vary a lot across Europe. And so what Eurocode 7 is doing is trying to harmonise those design methods so that engineers in one country know how to design structures in other countries. So there is considerable bringing together of ideas and some unification of ideas across Europe for the first time.
And across the professional disciplines as well. It's
yes, it's not just across Europe, but it's also between disciplines. So structural engineers have often worked to limit state codes where they're designing the structures in a particular way, but the geotechnical design codes have often adopted different philosophies because the materials are different. And this is the first time when those two sets of codes are actually going to be put together on a common basis, and hopefully there'll be better interaction between the disciplines.
But Andy, one thing that people have said about parts 1 and 2 of Eurocode 7 is it doesn't go into the detail that engineers are used to with the BS standards. So where do they go for that detail?
Well, it is true that the code is really quite short in comparison with the other codes that you might look at, like BS 8004, 8002. However, it then draws on a whole set of other documentation. There are what's called execution standards, and there's many of those telling you how to install a pile, for instance, or something like that. And there are other international standards that cover things like geotechnical testing and laboratory testing and that sort of thing. And we don't even lose parts of BS 8004 because it's being altered and made so that it doesn't conflict with the Eurocode. So there are lots of information. There are complementary information, things like the book, for instance, and other books that are written to enable people to have all that detail that is still available. So we don't aim to lose the detail, it is there, but the code itself is indeed quite short.
Except, of course, Andrew, engineers are traditionally quite sort of established people. They like, you know, they like their established rules, don't they? So
yes.
Is there going to be some reticence, do you think, in accepting the changes?
I think like all people, change is something that you are uncomfortable with to begin with until you understand what the benefits are. And certainly people could continue to work with their existing codes, but the big advantage that these codes bring is this link into the structural design, the fact that you'll be able to work with other engineers in Europe. So there's a lot more to gain by going to the new than you will lose by abandoning the old code. So overall, it's a very positive move.
Excellent.
But it's going to take time for people to become comfortable with that change, particularly engineers who are very used to dealing with things in a previous approach will find it quite difficult to move and feel comfortable they're going to produce designs that are safe and going to work effectively.
Well, let's start working our way through it right now to
Okay.
make people more comfortable with it. Let's start then with our look at some of the major concepts behind Eurocode 7. Design requirements. Andrew, perhaps one of the most significant requirements of Eurocode 7 is the commitment to limit state design. Now, can you tell us exactly what this means?
Well, limit state design involves looking at a number of states that you do not want this structure to reach. Some of these are ultimate limit states, so this is involving failure of the structure, where the safety of people and the safety of the structure are at risk. So we try to avoid those states, and we do calculations to prove that none of these events will occur. We also have another group of states called serviceability limit states, which is more to do with the functioning of the structure, the appearance, the comfort of people. We also want to avoid these being reached, and so there are separate checks to look at those limit states. We've always done this in the past, but not in as formal as a way as the Eurocodes require. So this is bringing a certain amount of rigour to our design, which was absent in the past. And generally that's a good thing as well.
So limit state philosophy has always been used for steel, concrete and masonry, but where these structures met the ground was always a source of analytical difficulties. So Andy, what will the new approach mean in practice?
The new approach will mean we talk the same language, which I think is a great help. So we will understand, as geotechnical engineers, we will understand what the structural engineers are giving us in terms of loadings from that structure or actions in a Eurospeak word. We will understand those things clearly, how they've been derived, and then be able to use them effectively in an analytical technique, and then give back particular bits of information back to the structural engineers in a way they will understand what we've been doing with them, so we can talk the same language and avoid any misunderstandings that currently can happen between the requirements of different professionals doing very similar things.
Well, let's take a look then at our second major concept. Complexity of design. Now, Andrew, presumably a welcome requirement of Eurocode 7 is the mandatory assessment of risk. So let's look at that one. What does that actually mean in practice?
Well, it's something that actually pervades all of the Eurocodes. The head code, which looks at basis of structural design, introduces the concept of classes of consequence, depending on how important the structure is, and reliability classes. And in the same way, the Geotechnical code introduces geotechnical categories. And the idea here is that you want to categorize the amount of risk involved in the design so that you can have larger partial factors for the more risky designs. You can have more appropriate supervision of the works. You can put in more testing of the works. And so there is a requirement in Eurocode 7 to categorise the risk, put your parts of your structure in these different categories, and then proceed with the design in an appropriate way. And there are particular clauses in the code which come into play for the category 3 structures, which is the higher risk. And there's different techniques that you would use for structures with lower risk.
Can you just give me an example? What do you mean? What sorts of structures?
Well, the higher risk structures would be things like large bridges, stadium, where there's a lot of people going to be in the structures. So there's considerable investment in that, and maybe extremely expensive structures. So those are generally the category 3 structures. Whereas category 1 structures might be very simple footings or very small walls that you also need to build. They all need to be designed in a similar way, but clearly the consequences of something going wrong is very different between them. So the code recognises this and gives rules which are appropriate to the different type of risk.
And to help engineers classify risk, Eurocode 7 introduces 3 geotechnical categories: their design requirements and the design procedures that they imply. So Andy, can you talk us through those?
Yes, Andrew has just alluded to the fact that there are these 3 categories that we have in Eurocode 7. Category 1, Category 2 and Category 3. It's quite simple really, and they relate to Category 1 structures are all the simple structures, things where you don't really need to do any quantitative analysis. So don't do any numbers, you can just use a rule of thumb to solve the problem. So that'd be a very simple foundation on well-known ground conditions. Category 2 structures are the majority of things that we design. Buildings, some small bridges, various cuttings, embankments, all that sort of thing that we do for civil engineering. They would require quantitative analysis. In other words, we'll have to do some numbers to work out the forces and stresses in these structures and do a design accordingly, according to the principles of Eurocode 7. And then there are category 3 structures, which are the more demanding structures. A power station, for instance, or a big hydroelectric dam and all those sorts of things, or very seismic related design. They do not really come under the main aspect of Eurocode 7. However, the general principles of Eurocode 7 will still apply, but you might want to adjust the partial factors or treat them in a slightly more conservative manner, have a greater amount of investigation or whatever.
Well, you mentioned ground conditions there. Presumably they might change throughout Europe.
They do indeed. They're very, very variable. So what you might want to do in the UK may be a very different thing that you might want to do in Norway or Spain or somewhere like that. The conditions vary, the geology varies, the sorts of problems that you might expect to experience vary. The climate varies, very different climate from Northern Europe to Southern Europe. So there's a whole lot of different things going on there, and the Eurocode is trying to provide a framework for all those possibilities. So it's quite a complicated issue from that point of view.
Yes, I'm sure. Well, let's move on now to the third major concept: limit states. Now, when designing a structure, the engineer needs to identify the possible ultimate and serviceability limit states likely to affect the structure. So, Andy, can you explain a bit more about that for us?
Well, ultimate limit states are those states that are going to affect people. They might possibly lead to severe issues for people, like death even. So they could be, you don't want people to die, you want people to feel safe within the structure. So the structure has to be safe from the point of view of people, and it also has to be safe from the point of view of it falling down, maybe without harming people at the same time. So that's the ultimate, those sorts of failure situations. Serviceability is about use. Does this building fulfill its function? Will the doors stick because it's moved a little bit? Or will the cladding fall off a building because it's moved a bit? Those sorts of things are the issues that we're looking at. Will you feel too much vibration being generated through the building? These are the sorts of things that are going to be governed by serviceability limit states.
So, Andrew, what ultimate limit states should be checked then for geotechnical structures?
Well, there's a range of limit states, and they will vary from structure to structure. But what Eurocode 7 does is it puts forward 5 different categories of ultimate limit states. The first one deals with equilibrium of the structure. This is concerned with the structure just toppling, falling over. For example, if you had a wind turbine, is the foundation wide enough for it to take the wind forces on it without it just falling over? So that's equilibrium. We also have to make sure that the ground is strong enough to take the pressures and forces applied to it by the building. So that's a geotechnical limit state. We also have to make sure that the concrete and steel that form the foundation is strong enough. So that's a structural limit state. So that's 3 of the 5. And then in geotechnics, we also have the possibility of uplift. When you put a basement into the ground, you dig out the ground, you put a structure in. The question is the building that you put back as heavy as the ground that you've removed? Because it isn't. If it isn't, it's possible for that building to lift up out of the ground, which is rather a strange phenomenon, but that's uplift, and we check that that doesn't occur. And then the final ultimate limit state category that Eurocode 7 requires is to do with hydraulic failure. And that's when you have a flow of water through the ground. And if that flow of water gets too rapid, then it can cause particles of soil to move with it, and you can have cavities appear in the ground and phenomena like that. So there are quite particular rules in the code which try to prevent that sort of limit state from occurring. So in summary, there are 5 different categories of ultimate limit state which Eurocode 7 specifically requires you to check.
And I'm just wondering as well whether you have to allow for the effects of global warming, with for example, adverse weather conditions, and try and predict what might happen in the future. You mentioned water flowing through the ground, and the chances are that that is going to increase in the future.
Well, one of the things that you have to do for all structures is to determine their design working life, how long you want this structure to work for. And that may be 50 years, for major structures it could be 100, 120 years. And so engineers are predicting the sort of actions that will apply to that structure during that time period. And that will include climatic changes. A particular phenomena in London, for example, is rising groundwater due to the fact that we're no longer pumping water out of the chalk aquifer at depth. We've stopped doing that. So the groundwater is coming up, and engineers are quite used to designing their basements for this rising groundwater. So yes, those things do have to be taken into account in the design.
And of course the serviceability limit states as well.
Yes, they're very similar in the sense they are criteria that you have to meet. So you might decide that a building can only settle, let's say, 10 millimetres, or it might be that you can allow 50 millimetres. You have to decide what those things are in terms of what you might expect the performance of the building to be, and then design accordingly. So you set a serviceability limit state, something you can say, we can go this far and no farther under the working conditions, and the building or the bridge or the embankment will perform in a satisfactory manner. So that's really about serviceability. Assessing what those boundaries are is sometimes quite difficult to do, and then we have to predict what will happen during the lifetime of the structure. So again, we're trying to look at what happens over maybe 100 years or maybe more.
And so to our next major concept. Geotechnical actions. The code lists 20 different types of actions that should be included in geotechnical design. So Andy, are these all fairly straightforward? Are they all obvious?
Most of them are. There are things like the weight of the soil or the pressure from the water that's acting on a retaining wall or something like that. So they're fairly straightforward things. But there are other things that maybe not quite so obvious, like temperature change. Temperature change induces movements, and you need to allow for those in the design. So you've got to think about other things. Frost action is something that ground freezes. Again, that will induce movements in the ground, which will then affect the structures that we build. So we have to look at other things other than just the purely obvious.
And there's a distinction, Andrew, isn't there, between favourable and unfavourable actions?
Yes, and this is sometimes quite a difficult thing for people to grasp. Favourable actions are ones where the action generally is not leading to one of these limit states. So it's generally beneficial to us. And in those cases, we're not going to factor the action. We're going to take it at its base value. With the unfavourable actions, these are tending to be the actions that are causing the limit states that we're trying to avoid. So those are the actions that we're generally going to increase in our calculation to take into account the lack of reliability, the lack of knowledge about the magnitude. So we want to margin in on them. And so if we have to distinguish between the ones that work for us and the ones that work against us. And so this distinction is a key part of Eurocode 7.
Well, let's move on then to the next major concept behind Eurocode 7. Geotechnical design. Geotechnical design is much more complex than design in other materials. So Andrew, what does the code say about verifying limit states?
Well, it presents a number of different ways of verifying these ultimate limit states and the serviceability limit states. And we need a variety of methods because the soils do vary greatly between different countries. So over many years, different techniques have evolved. One of the methods is to do a calculation. So you try to work out all of your actions and your resistance of your material, and you check that your actions are less than your resistance. That's fine for a lot of structures, but in some cases you may not have enough information to do those calculations, in which case you can use what are called prescriptive measures, which are simplified rules of thumb, which are generally very conservative, and you can use those to check that you won't reach a limit state. So that's permitted as well. The third category of verification that you can use is by some sort of testing. This may be a physical test, a small-scale model test, or it may be some sort of field test that you take the results from and then work out your design. So you can also do design by testing. And the final category is what is called the observational method, which is quite a well-established and well-respected technique that's been going for many, many years. And you can use this, and this is whereby you do a design and then you modify that design based on observations you make during construction of the works. So it's almost sort of sucking it as you see. You know, you go along and you make adjustments, you have thresholds, and when your design moves outside of the limits that you set, you adjust the design to bring it back in. So any of those techniques can be used, and those are all permitted by the code.
Well, Eurocode 7 presents 3 different design approaches for carrying out ultimate limit state analysis. Andy, can you tell us about those?
Yeah, there are 3 approaches. That's because essentially the code was developed across Europe and each country has its own way of doing things, and it was impossible at the code drafting stage to come to a common agreement on one approach. So there are 3 approaches: Design Approach 1, Design Approach 2 and Design Approach 3. Design Approach 1 is the one we are going to adopt in the UK, and that has 2 combinations within it, so you have to do 2 sets of calculations with Design Approach 1. And essentially these approaches differ by the way in which the partial factors are applied. In Design Approach 1 we factor, combination 1 that is, we factor the loads, the actions, and not the material properties. In combination 2 we basically factor the material properties and not the actions. In Design Approach 2 they factor both the actions and the resistances at the same time, and in Design Approach 3 they factor the actions and the material properties at the same time. And it depends on which countries, the country's approach to design that they wish to adopt one or other of these approaches. And each approach has to be specified in something called the national annex, so a country will decide they're going to use one or other of these 3 approaches.
And if a British designer is working, say, in Spain, which approach do they go with?
What they do then is they look at the national annex for that country, and if the national annex says they're going to design slopes to Design Approach 3, then they should use Design Approach 3 to analyse those slopes. But it should be open and transparent so that British engineers can work in other European countries and vice versa.
So although you may be designing a structure for one country in a different way that you would design it for your own country, you will know the rules that you've got to follow. So the big improvement that Eurocode gives you is that you understand the rules that apply in the country where you're building the structure.
Well, let's have a look now at our penultimate concept. Supervision, monitoring and maintenance. Andrew, what's said in the Eurocode about supervision?
Well, there isn't a lot of detailed guidance given in the code, but the designer is required to consider supervision, monitoring and maintenance, and has to prepare a plan of supervision as part of the design. Now, the amount of detail that goes into that plan depends on the geotechnical category that the structure has been placed in. So if it's geotechnical category 1, the negligible risk category, then very little supervision is necessary. But if you're in geotechnical category 3, the more important structures, then clearly you're going to have a lot more supervision, you're going to have a lot more detail. The key point here is that the designer has to decide what is appropriate for the structure he or she has designed, and has to state that in a plan which becomes part of the design.
And what about monitoring, Andy?
Again, very much based on the category that you assign to the structure, we would specify what needs to be monitored. So you might be monitoring the movement of a building or a bridge or something like that, monitored on a regular basis to ensure that it's meeting the design criteria so that you can be confident it's going to perform in the future.
And now let's have a look at our final area. Ground investigation and testing. In part 2, there's detailed guidance on how to derive geotechnical parameters from field tests and laboratory work. And that seems to me as if that would be really helpful.
Yes, it is very helpful, because up to this point there's not been written down how much testing you should do, how much site investigation you should carry out. There's guidance and people's ideas, but nothing really formal has been written down. And what the Eurocode does it must say in an annex to the code, which means you don't have to follow it, but it gives guidance about how much investigation you should carry out, how many boreholes you should put in the ground, what their spacing should be as a minimum, and therefore it gives quite clear guidance to people as to about how much work should be done in investigating and trying to understand the properties and variability of the ground, which is indeed a very variable medium. And what's been done at the moment is people try to cut down on what is done, do the minimum, very, very minimum, and that can cause potential problems to design and can indeed lead to a lot of wastage in terms of money and time in projects. So this is very important.
Specific, isn't it? But does it go into things like, as much detail as, say, the depths of boreholes and things like that?
Well, it does, yes, because it says that for a structure that is so wide, they need to go down so deep. So that is at least that depth. So that is indeed giving a much more guidance. And one of the cries of the industry, let's say from a piling engineer's point of view, is that they get so many investigations that don't even reach the bottom of the pile that they're going to put in the ground, and that is not good enough.
And presumably, Andrew, the geotechnical design report is a key feature as well.
Yes, in the good old days you used to have a factual report and an interpretive report, and these have now been replaced by what is called a ground investigation report and a geotechnical design report. And there's quite specific contents for each of them which are set out in the code. And the design report in particular is a key document. It sets out all the principles of the design. It talks about where the data has come from to base that design on. It will give the calculations. It'll include these plans of supervision, monitoring and maintenance. It'll talk about the actions. It'll talk about the risks. So quite a comprehensive report. And that has to be produced for all designs. So people are going to have to write down the assumptions on which their design is based, and that formal document has to be available for others to look at a later date.
Well, gentlemen, we're almost out of time, but I'd be very curious to know how you think Eurocode 7 is going to develop in the future. What do you think, Andy?
I think there's going to be, it's going to get used, obviously. It's a statutory requirement it gets used. But I think there's going to be quite a lot of debate about how you apply the various principles in a rational and uniform manner, both within the UK and across Europe. And that's going to lead to people thinking, well, we might want to move or change some of these partial factors, for instance, because we're not quite sure the number's quite correct here, and people are going to argue and discuss this as they get into using the code. So there's going to be a lot of change and a lot of people thinking about how we're going to apply this effectively and uniformly, particularly where one person does one part of the design, someone else does another, and they adopt slightly different interpretation of the rules. They've got to meet together and come to some common agreement, and there's going to hopefully be more guidance and greater clarity on those issues.
Now, Andrew, of course, I can see you looking very thoughtful here. he's thinking, well, below me, I've spent all this time, working on this code. I haven't actually looked to a son of Eurocode 7.
Well, unfortunately, I do have to now because I've now taken on the role as chairman of the Eurocode 7 committee, so I am very much looking forward to what needs to be done in the future to this code, what changes need to be made, even though it's only just coming into effect.
I should say the ink's not dry yet.
Absolutely. But like all things, it's a first version. And I think that when we see this code being used in practice, and certainly from the feedback that we've had from our training courses, when practicing engineers are trying to apply it, there will be issues that come up that we could do better on. And so I think that those of us who are involved in drafting the code need to address those. We need to look at the key issues. And the feedback we're getting from practicing engineers is that they want more guidance, they want more definitive guidance on what calculation models to use, they want better advice on how to determine water pressures is a big question. How they select the material properties for the soil is a very important question for them as well. So they want more. However, they want a simpler code. So they want more, but they want it presented in a simpler way. So these are two opposing things that we've got to somehow, that's the challenge, we've got to somehow put that together. I'm sure we can do it, but I mean, to begin with, I think we need to see how people take this code on and how they work with it and learn from that experience, and then son of Eurocode 7 hopefully will be even better.
And hopefully you'll then come in and talk to us about that as well.
Be happy
Thank
to.
you so much indeed for coming in and helping us decode Eurocode 7. Now don't forget, there's much more in the study notes that accompany this programme, so do have a look at those. However, for now, from all of us here in the studio, goodbye.
Goodbye.
Thank you very much.